Hello, and welcome to a video on problem solving part 2, brought to you by the Answer series. I've got 2 examples here for you. Again, notice there are words, so we need to be careful. We need to be able to see from the words, what are we trying to get? So I want you to pause the video, I want you to try these, and then we'll look at them together. The first question asks you for the sum of the digits of this product. Now these numbers are very, very large. If you use a calculator, it just says maths error. So we've got to find a way of doing this. You will notice the bases are different and the indices are different. They've asked us for the sum of the digits. Now, if we've got a very, very big number, we're not going to be able to get the sum of the digits if the digits are all sorts of numbers. So there has to be something we can do in this one. And we need to remember that a to the m times b to the m is equal to ab to the m. In other words, if I've got the same power, I can multiply the bases and my power stays the same. Now, if I look at the bases of 2 and 5, I know that 2 times 5 is 10. And if I then want the sum of digits involving a whole lot of tens, that's going to be okay to do. So what I do is I'm going to take this 5 to the power 2025 and I'm going to split it up. Because this is 2 to the power 2022, I'm going to break up the 5s so that I've got 2022 of them and another 3 of them. Because remember, when you multiply, you add your powers. Now what I'm going to do is combine these two. And I'm going to use this law. And because the powers are the same, I may multiply the bases and get 10, and my power stays the same. Now, 10 to the power 2022 is 1 with 2022 zeros after it. 5 cubed is 125. And if I take 125 multiplied by 10 to the power anything, I get 125 and then a whole lot of zeros. The question said, what is the sum of the digits? So the sum of the digits is 1 plus 2 plus 5 plus many, many zeros. In other words, my answer is 8. In the next question, they've asked me for the sum of the units digits of this particular sum here. Again, if I use a calculator, it tells me an error. So we need to start with something small. So let's start with 3 to the 2022. 3 to the 1 is 3. 3 squared is 9. 3 cubed is 27, but they only want the units digits. So 3 cubed ends in a 7. 3 to the 4 is 81, which ends in 1. 3 to the 5, well, if I take 81 times 3, it's going to end in 3. And you will notice that my units digit cycles through 3971, 3971, 3971, and that's it. So I take 2022 and I divide it by 4. I get 505 remainder 2. So that tells me there are 505 of these groups. Now that's not important to what I've been asked to do. What is important is the remainder, because remainder 2 tells me that I'm 2 parts into the next group. In other words, the units digit is going to be a 9. I do the same thing with 4 to the power 2022. So 4 to the 1 is 4. 4 squared is 16. It ends in a 6. 4 cubed is 64. It ends in a 4. And so on. And what do you notice with 4? Well, it ends in either a 4 or a 6. If my power is odd, my number ends in a 4. If my power is even, my number ends in a 6. Because 2022 is even, it means that 4 to the power 2022 ends in 6. What about the 5s? 5 to the 1 is 5. 5 squared is 25, it ends in 5. 5 cubed, 125, it ends in 5. And 5 to the power anything always ends in 5. They asked me for the sum of the unit's digits. So this one ends in a 9, this ends in a 6, this ends in a 5. The sum of the unit's digits is 20. The next example is a word problem. It says to you, find two numbers so that the sum, difference, and product are in the ratio 4 to 2 to 9. So I want you to let the two numbers be x and y, and I want you to pause the video. I want you to try this, and then we'll look at it together. I'm going to let the numbers be x and y. So the sum is x plus y. The difference is x minus y. The product is x times y. And they must be in a ratio of 4 to 2 to 9. So what I now do is I take these. That over that must be equal to 2 over 4. So there's one of the ratios. I cross multiply and I simplify, and I get that x is equal to 3y. I then take this one over this one, which must equal 9 over 2. Again, I cross multiply. Now, this x here and these x's are exactly the same. So what I do, in place of these x's here, I put 3y. So this equation becomes that. I then multiply, set up my quadratic, factorize, and I get my two values for y. Have a look. If y is equal to 0, then x is going to be equal to 3 times 0, which is 0. So then my numbers are 0 and 0. X plus y, 0 plus 0 is 0. 0 minus 0 is 0. 0 times 0 is 0. That's not in the ratio 4 to 2 to 9. So y cannot be equal to 0. The only answer I can have is y is equal to 3. And if y is equal to 3, then x must be equal to 9. And with word problems, always check your answer. So if x is 9 and y is 3, the sum of the two numbers is 12. The difference, 9 minus 3, is 6. The product, 9 times 3, 27. 3 goes into all of those numbers, 3 into 12, 3 into 6, 3 into 27, and the ratio I've got is exactly what they gave me. So there's that one done.
If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from The Answer Series, your key to exam success.